Back with the second example here, a little bit more complicated than the first. We've got two functions again, f and g. They are continuous. We know that the integral from 0 to 7 of f of x dx is equal to 15. We also know that the integral from 4 to 0 of g of x dx is equal to 8. And the integral from 4 to 7 of g of x dx is equal to negative 12. That's given to us. Our task is to find the integral from 0 to 7 of 1/5 f of x minus 2g of x plus 4 dx. Okay, so we're putting a lot of our properties into play here again. So my guess is initially you looked at this one right away and the bounds being reversed caught your eyes. So we do know that if we were to change this from 0 to 4, all that would do is make the 8 a negative. So there's one thing we can do to start off. The integral from 0 to 4 of g of x dx is equal to negative 8. Now we can use another one of our properties, which is that if we have from 0 to 4 of g, and then we have the integral from 4 to 7 of g, we can actually put those together. The integral, I'm going to do the shorthand, the integral from 0 to 4 of g plus the integral from 4 to 7 of g is equal to the integral from 0 to 7 of g. That's the whole, a whole is equal to the sum of its parts. So because we leave off at 4 and then pick up at 4, this is nice and continuous. I think that's right in the line of the light reflecting off the board, so I apologize. 0 to 4 of g is negative 8. 4 to 7 of g is negative 12. So we have negative 8 plus negative 12, and that's obviously going to be equal to negative 20. Okay, so now we have the integral from 0 to 7 of g valued at negative 20. We know the integral from 0 to 7 of f is valued at 15, so we can use these two numbers as we begin to break down our overall problem. All right, so let's see if you can do this a step ahead of me doing it. We want to break this down into multiple integrals and then start to come up with our answer. So feel free to pause the video at this point and give it a shot. If you're not quite sure, then you can work with me or perhaps slightly ahead of me. Here we go. The integral from 0 to 7, we're going to move the 1/5 out front because it's a coefficient of f of x dx. That's our first integral. We then have minus. We're going to move the 2 out front, and we have the integral from 0 to 7 of g of x dx. And finally, we are adding the integral from 0 to 7 of 4 dx. Okay, so that's our breakdown. Now we can do our substitution. 0 to 7 of f, that's 15. So we have 1/5 times 15 minus 2, and then the integral from 0 to 7, we found that to be negative 20. So we'll sub that in. Okay, in this problem, the integral from 0 to 7 of 4 dx is like the previous example 1b there, where we just have a constant right there. That is a horizontal line. Perhaps we could do this without drawing the graph. There is a quick way to do it. The base of our rectangle will always be the difference between the bounds. So the base is going to be 7. The height of the rectangle is going to be our function 4 there, y equals 4. So we have a base of 7 and a height of 4, and 7 times 4, yeah, that's going to be 28. Okay, so again, if you're not quite sure how the 28 came into play, you can draw a graph and see how the rectangle will be formed with a base of 7 and a height of 4. But again, the drawing is actually not necessary. You can do the mental math by subtracting the bounds and multiplying it by the constant. Okay, so here we go. 1/5 of 15, we know that that's equal to 3. And then negative 2 times negative 20 means we're going to add 40 there. And then we have to add 28 more. So 43 plus another 28 will give us a final answer of 71. So if you came away with 71 before I got there, fantastic. Hopefully these are going better for you. If so, go right ahead and work on the homework. I'm going to do one more example, and this one's going to involve a graph.